working with measurement numbers. So the main thing that we're gonna see from this section, and something that you probably have seen in your science class, is the significant digits. And so in the significant digits, we have a couple rules. Rule number 1. Digits other than 0 are always significant. Rule number 2. A 0 is significant when it A appears between two significant digits, B is at the right end of a decimal number, C is marked as significant with an overbar. So with the third rule, it's just when is it not significant, and so with the first one is not significant when it's at the right end of a whole number and when it's a left end of a number. So let's look at this rule. So rule number 1 example. Let's think of 84.2 rotations per minute. As long as it's not a 0, it's a significant number. So in this case, how many significant numbers do we have? So we have 3 significant numbers. As long as none of them are 0, it's always a significant number. Rule number 2A. We're going to consider 3,206. RPMs again. So, how many significant numbers do we have for this one? So in this case, we have 4 significant numbers. Because as long as the 0 is in between 2 numbers, we'll count that in. Let's look at rule number 2B. And we're going to consider the following one. So it's at the right end of a decimal number. Okay, so in this case, 24.0 volts. We're trying to see how many significant numbers we have in this case, and so how many do we have? So we have 2, because B says at the right end of a decimal number. So if I have a 0 all the way at the end of the decimal, that one is not significant. So we can just consider this as just 24. So So that's the reason why this is only two significant numbers. Then we have rule number 2C. So if we have something like this, 24, 240 volts with the little bar on the top. In this case, how many significant numbers do we have? 3, because as long as it has an over bar, this is 3. Cool. Let's look at 3A. Okay, so for rule number 3A, let's think of 240 volts. How many significant numbers do I have? 2, because remember, if it doesn't have the little bar on the top, then it's only 2. Rule number 3B, 0.025. How many significant numbers do I have in this case? Okay, the next thing that we're going to look at is precision versus accuracy. Okay, and so for precision is a number, so it's a measurement oops, here, I should have wrote it this way. Okay, so when we're looking at precision and accuracy, our precision is of a number of the precision of a measurement number is indicated by the place value of its rightmost significant digit, while the accuracy refers to the significant digits that it contains. For example, when we're looking at 4.01 seconds, and we want to state what the measurement is, so the measurement is precise to the, so we're looking at the number on the right. So in this case, we have a 1 on the right, and this is in the hundreds place. So this is precise to the nearest hundreds of a second. So that's how precise we know it is. Now, we also know that it is accurate to 3 significant digits. If we were to look at the second example, 40 seconds. So, we need to look for the digit numbers. Any 0 to the right, it doesn't count. So then in reality, we'll only have one digit number in this case. So we could say it's accurate to one significant number. So it's accurate to one significant digit. And how precise is this? The number is precise to the nearest 10. So it's to the nearest 10 seconds. At this point, we just got 2 more things. And so we're going to look at tolerance. That's something that we will see. So for the tolerance, think of a Subway. So for Subway, we can buy a full long, right? So we can get a full long sandwich. And we know that it's supposed to be how many inches? So if this is 1 foot, it's supposed to be about 12 inches. But have you ever really measured one of your footlongs? No, right? Because we assume it's pretty much the same, like it's going to be about 12 inches. And that's what that about to be means. So the tolerance means how willing are we for it to be within that measurement that we're looking for. For example, if you were to measure them, they're usually allowed to be between 11.5 inches to 12.5 inches. And so what we're saying here is, for my sandwich, the tolerance for my Subway is 12 inches, give or take half an inch. All right. So for the last thing that we're doing is, what do we look at measurements? So, for example, the last thing that we're going to look at is visualizing units. And so for the visualizing the units, we're looking at, for example, we have the first unit, which is an inch. And in this case, what this tells me is a one-dimensional or linear measurement. Then from 1 inch, we can actually look at it a little bit different. We could actually have 1 square inch And that is a square that is 1 inch long and 1 inch wide. So this is a square inch. And at this point, what we're looking at is a two-dimensional measurement. So today's activity for SolidWorks, so the thing that you're going to be designing today, it's an actual two-dimensional. So that's what you're going to be creating. The way to write this is, if I'm looking at inches, I'm looking at inch square. So I put a little square on top of it, and that's what's telling me that I'm looking at a two-dimensional. Besides having a square, then we go into the third dimensional measurement. So in this case, we're looking at an actual cube. Where everything is 1 inch. So this is my cubic inch. And we're looking at the three-dimensional. Measurement. And this is denoted by an actual power of 3. And so what's going on here? So in this case, we're looking at just the 1 inch. That's the reason why we only call it that. In this case, what we have is we have a length of 1 inch multiplied by another inch. So that's the reason why we have 1 inch square, because inch times inch is inch square. And in the other case, because we have a length of width, and then we have how long it is towards the back, and we're in a third dimensional, then we have 1 inch times 1 inch times 1 inch. So this is 1 inch cubed, because we have 3 of them multiplying each other. In some cases, as we have the last one, where we know that a car is going 24 miles and it takes them 1.5 hours to reach its destination, then what we're doing here is we're actually just doing a simple division. 24 miles divided by 1.4 hours, which translates into 24 divided by 1.5 miles in hours, which when we work this out, this is just 16 miles per hour. Alright, so here, let's do the last one. Let's say you're trying to fix part of the floor, so single part of the wood on the floor, and you ask your sibling to measure it out. And your sibling gives you the following measurements that he found or she found. 4.35 feet by 3.6 feet. And so you have to go and try to get another piece of wood that will fit this part. So, as I try to get this from my feet square, let's find out what our feet square is for this. So we're going to have 4.35 feet times 3.6 feet. When we multiply both of those, what we get is 15.66 feet square. Considering our significant digits, we're going to consider each one. This one, how many significant digits does it have? It has 3 significant digits. What about the other one? How many does it have? That's about 3.6. So the number's 3.6, so it has 2 6 figures. So when it comes to rounding, you're always going to round to the one that has the least amount. So I'm going to round my number to 2 significant digits. So in reality, once I round 15.6 feet square to my least amount of significant numbers, this is just 16 feet square. Cool. And that's it for this lesson.